Right, so Year 8, Earth and Atmosphere Knowledge Test, right? This will then probably be repeated in Year 11 right at the very end, okay? So knowing it now is going to benefit you right at the end of Year 11. Label the structure of the Earth, right? So the outer layer is the crust. Next layer in, the mantle. Then you've got the cores. You've got inner core, which is obviously the very bit in the middle of the yellow bit, and then you've got the outer core. What is the difference between magma and lava? So magma and lava. Magma is molten rock underground, okay? So if you're going to dig down, right, and you came across molten rock, that would be your magma. Lava is molten rock on the surface. So as soon as it comes out naturally, right, out of a volcano, it then becomes lava. What are the properties of sedimentary rock and how do they form? And give 2 examples. Crikey. Right, so properties of sedimentary rot. Properties of sedimentary rock is the fact that they're in layers. They will often have small grains and there will be fossils. Right, now the way that they actually form is, let's say there's one that's forming underneath the sea. Alright, so that's the top of the sea, that's the bottom of the sea. And what happens is loads of particles just fall in and they sink to the bottom of the sea, and eventually what they do is they go to the bottom. Then what happens? More particles, then some more particles, right? And then when I've got some more particles, etc., you get the picture. Then what happens is you get lots of pressure, and the pressure then squashes all the particles together to form the layers of rock. Examples are limestone and chalk. Okay, igneous rock. Right, so what I've got here is I've got my volcano. Right, there's my volcano. Right, and what happens is you've got your tube up the middle where all the lava comes out. Igneous rock is the stuff that's come out, right, and there's then the rocks that are formed here, right, which is then the igneous rock. It's the lava that has then come out that has then cooled down. What they tend to have is they will tend to have interlocking crystals. The crystals are disorderly. They never have fossils, because obviously if you think they've come out of a volcano, so any fossils will then be destroyed. And it is when magma cools. Best examples are basalt and granite. Metamorphic rock. Right, now metamorphic, I love the word metamorphic. Morphic means change. So what I'm going to do is I'm going to draw my terrible volcano again. Right, there's my tube that goes up the middle. Right, that bit there. Right, this time metamorphic rock is the rock that is here. Alright, and what it is, it's changed by the magma coming up inside the volcano. Alright, so there tends to be larger crystals. It is denser and harder than the other rocks. It is formed by huge pressure and huge temperatures. And the best examples are marble and slate. Complete the table. Nitrogen, right, so these are then the gases that are then in the atmosphere. Nitrogen, 78%. Now these numbers vary slightly, all right? So nitrogen, oxygen is 20.9%, right? Sometimes it's written as 21%. Argon is 0.93%. Carbon dioxide 0.03, and other gases 0.14. Now theoretically those numbers should add up, right? Which I don't think they do, they're just kind of slightly out. Right, so that could be, you know, there's like 1/100th out, I think, or something like that. Now, what you'll do is when you actually get a table like that, they do vary quite a lot, right? But these are then the numbers that you need to fill in for the test. Draw and label the carbon cycle diagram. Right, now, what I could do is I could go through the whole cycle, just explain it, right? But to be honest, it's quite difficult to actually do. Right, so what I would do personally is I would start off with Mr. Sheep in the middle, right, and what you're going to have to do is you're going to have to get a piece of paper and you're just going to have to keep on writing it out. But think about Mr. Sheep in the middle, respiration. Mr. Sheep in the middle, dead, right, and then what happens to it. Once you've kind of sussed out what's happening to Mr. Sheep, think about where the respiration is going. Think about then where the different parts are then going. And if I was you, what I would do is I would start with Mr. Sheep and the bits. Start with Mr. Sheep and the bits going up to kind of the outside of the circle. So this circle, what colour shall I do it? I'll do it, yeah, I've just done yellow. I'll do it in red. No, I've done red already. I'll do it in blue. Then work out all the bits on this circle. So you've done Mr. Sheep, then you've done the circle itself, and then add on all the extra little bits, and then just kind of learn it as a diagram. So name 2 greenhouse gases and where do they come from, right? So we'll go CO2 and CH4. Where do they come from? Combustion, particularly of fossil fuels. Okay, it's also in things like cars, you know, all sorts of carbon dioxide is produced. Methane is from livestock, right, cows particularly. It's from rice, paddy fields and landfill. So each one of those are producing methane, right? So it's kind of cows' bottoms, rice paddy fields and landfill. Describe how the greenhouse effects keeps the planet warm. Now this is, again, it's going to be a diagram done by me. Right, and what you've then got to do is you've got to try and convert it into words. So how does it go? So there is planet Earth, right? What I'll do is I'll do a couple of countries on there, right? Looks like a disease more than anything. Bit of sea in between. Okay, there's planet Earth. Around the outside of it, then what we've got is we've got the greenhouse gases. That is supposed to be a circle the same size, and that contains CO2 and methane. Now we need that to a certain extent. We need kind of the CO2 and the methane blanket around the outside to keep the planet warm. If it disappeared completely, all the heat would go. Now what we're going to do is we're going to do big sun over here. Big sun is then going to shine light onto planet Earth. It goes through the greenhouse gases, nice and easily. But then when it hits Earth, what it does, it then changes its form and it turns into heat that then rises. Some of it escapes, some of it doesn't. The heat that doesn't escape warms up the planet. Okay, now from that what you've got to do is you've got to describe, where you need to then put it into words, right, what I've then just talked about. So just replay that little section again, right, and then just look at, right, what happens at each stage. So it's the building up of the greenhouse layer, which is the carbon dioxide and the methane. Sunlight gets through. Then when sunlight changes its form, what happens is then the heat rises, some escapes and some doesn't. It is literally a bit like a greenhouse. Okay, so this is a greenhouse, obviously, right, a cube greenhouse. Sunlight goes in, but then it can't escape. So what happens is the greenhouse gets warmer. Describe the steps for recycling glass. Number 1, collect it. Number 2, clean it. Number 3, melt it. Number 4, reuse it, and it goes back to a supermarket. Right, number 11, keywords. Right, so what I've got here is the breaking up or wearing down of rocks by the action of living things, biological weathering, right? Weathering is often sort of a word that is talked about quite a lot, right? Like wind weathering something, but biological weathering is when living things are breaking it down, like the roots of plants. A place where carbon and its compounds may remain for a long time. Carbon stores include the atmosphere, carbon stores. Often the sea is also a very good one, like sedimentary rocks, the sea, fossil fuels. The gluing together of sediments of different chemicals to make sedimentary rocks is cementation. Chemical weathering is the breaking and wearing down of rocks by the action of chemicals, acid rain. The process of squashing sediments together to make new rocks by the weight of layers above, compaction. The settling of sediments that have moved away from their original rock, deposition. The breaking of rocks into sediments and their movement away from the original rock, erosion. Physical weathering is the breaking up by the changing temperature. Porous material has small gaps that may contain substances in their liquid or gaseous state. Water can soak into them, a bit like a sponge. Right, words again. Right, lots and lots of words, and what you've got to be able to do is you've got to translate diagrams into words. Right, write it out, see if it makes sense. So write out any explanations, use the correct terminology all the way through, and when you've done that, what you can then do is you can then go to that test that I've then put on there as a blank video, stop each question, and then try and write down your explanations as you go through.